Okay, in this video, we're going to solve the problem number 5 in the 2019-2020 ACSL season, contest number 4 for the elementary division. So the fifth question is they're all in contest number 4 they're all graph theory questions. So in this question, it's about traversability. Okay, so identify the starting and ending vertices that must be used in order to traverse the following graph. If it is not possible, write none. Okay, so with traversability, we have to keep in mind that traversable graphs must have even number of an even number of vertices that each of these even number vertices each have an odd number of edges or degrees. Okay, so do we have so it could be 0 or 2. Okay, so either have 0 vertices that have odd, so we have no vertices or nodes with odd number of edges, or we have 2 vertices and both of these vertices have an odd number of edges. Okay, so as we can see here, we have so J, for example, right? So J, it has 1, 2, 3, 4. So that's even. So that would not be J. So J wouldn't be it. So J wouldn't be that. So we have C here, and we have 1, 2, 3. Okay, so we have C, and it has 3 edges. Okay, and we have another one. Could it be F? So F has 1, 2, 3, 4. No, F has 4 edges. No, that's not F. It's not F. Okay, is it G? How many edges does G have? 1, 2, 3. Okay, so G has 3 edges. So okay, so we have 2 vertices. Okay, we have 2 vertices that have an odd number of edges. Okay, so we have 2 vertices. Okay, two vertices. We have 2 vertices, so we have an even number. So again, you could have 0 or you could have 2. Okay, so you could have 0, 2. So we have 2 vertices, and they both have odd number of edges. Okay, so this graph is traversable. Okay, so we have so basically it's C and G. Okay, so we got C and G, or you could say it's G and C, or you could say it's G and C. Okay, so either one. Okay, so for example, we start at C, then we could go to D, then we could go to J, and then we could go to E, and then we could go to H, and then we could go to F, and then we could go to G. Okay, that's traversable, right? So we have a traversal. Okay, traversable. Okay, so we can start at one vertex, and then we can end at another vertex, and we're able to hit all the let me see here. So C to D, here, go back here. So I can, and also, so I also I can go, I can hit every edge without having to, oops, no, wait a minute. No, that's not true. Um, okay, so here, for instance, this example, right? I'm able to travel. I'm able to go. I'm able to travel and go and travel through every edge without ever, only once. Okay, so I can like I can start at C and then end up at G. See, okay, so like C and let's see here. Okay, so I can travel each edge without having to I can complete the graph and travel through each edge without backtracking on any of the edges. Okay, so the answer is C and G or G and C. C and G or G and C. It doesn't matter which order.